For this video, the intent is part of the third unit in the Intro to Organic Chemistry class. And in this unit, we're going to be looking at functional groups. So I thought we would start with understanding and interpreting skeletal structures. You can see there's two skeletal structures here. They look kind of weird. They're all just zigzag lines and other random elements added. So the point of this video is to understand these other notations for showing the molecules. Let's start by looking at this skeletal structure. You see that we have a zigzag line pattern here, and we have a downward line and another angle. And honestly, it kind of looks like a little face, but it is not. So what we're seeing here is actually it is the carbons. There's 1, 2, 3, 4, 5. So we're going to draw 5 carbons here. And then we have, coming down off of this third position here, we have 1, 2. So 1, 2. And then we can assume, because no other atoms are shown, we can assume all of these other spaces that would need to be filled for carbon's tetravalent bonding would be all filled with hydrogens. So this molecule is CH3, CH2, CH with a ethyl group attached to it. Maybe you draw it like this. Maybe you'd have a CH2, CH3 as your branch, and then CH2, CH3. So part of my next two slides are going to be how we interpret the information provided in this molecule drawing, this zigzag structure, the skeletal, so that we can figure out what is actually there. And sometimes it's easier to think of it in the expanded format, and sometimes it's easier to think of it in the condensed format. And even further, we might have to name it. So this is a pentane, and we have a 3-ethyl pentane because on the third carbon we have that extra ethyl group. So here are the rules with respect to drawing the skeletal structures. You have, we only draw carbons, and carbons are going to be represented as the lines. Each line has a carbon at each end, so anytime you see a line, we would assume that there's 2 carbons there. You can't draw a skeletal structure for a single carbon because you'd have to have just a dot. Each intersection, anytime that you see a zigzag, each intersection is going to have a carbon. So for this zigzag, we would have 3 carbons. We have to add all other atoms or multiple bonds. So when you have a multiple bond, for instance, if you had a zigzag that was going on that angle and this was the double bond, you'd have that double bond there, or a triple bond. So anytime that you've seen a picture with extra lines in parallel, that's telling you it's a multiple bond. When you can see up here, we have a bromine. We have actually 2 bromines attached to this skeletal structure. And for any of the other atoms that are connected into your molecule, you have to show all other connections. So if it is just the bromine, those would all have the unshared electrons around it. But if you look down here in this case, you see an oxygen that's connected to a hydrogen. So you have to indicate all the other atoms that are connected to all the other connections. Any of the other spots are assumed to be connected with hydrogens to fill up the tetravalent features. So you have the 4 bonds. So this zigzag up here in the upper right would be a CH3, CH2, CH3, or it is a propane. Once you get the hang of reading these structures, they're not too bad. Some people will actually be able to look at them and interpret them right away. Some people will need to be able to sketch them out in the regular molecule structure. And some people can just name it. You still follow all the other normal rules. So, this one has 1, 2, 3, 4 is 1, 2, 3, 4, 5. Sorry, 5 is the longest chain, so this is a pentane. And it has 2 bromo groups, so I'm gonna run out of room, but we're gonna go one, this is carbon 2 and 3, and this is dibromo. And then we have this 1,2 group here, so that is dibromo. It is a 3-ethyl pentane. Now this other one over on the right, I'm not going to name it out because this is actually not named as it appears. We don't know enough information about it yet. We haven't learned about these other groups. But if I wanted to draw it out with all the atoms in it, I'm going to go ahead and sketch this benzene group, this phenyl group. There is a carbon at each intersection. Let's go back and do a different color. Oops. Let's put that back in. We're going to go ahead and we're going to do red. So there's a carbon at each intersection. And then you have another carbon with a double bond oxygen and an OH connected. You also have, off of this one, you have another OH connected. So this oxygen would have its lone pairs. This oxygen would have its lone pairs, and then all of these other hydrogens would come off of the carbons. So it can be simple once you know the 1, 2, 3, 4. Once you know the rules to interpret them. Some people find it easier to look at the pictures and go back to the expanded, and some people look at the expanded and can condense them right down. So skeletal structure is also known as zigzag.